Drop a block of iron into water and it sinks straight down. But a ship made of iron floats. Tens of thousands of tons of steel floating on water. Iron sinks, yet an iron ship floats. We all accept it as perfectly normal, but when you stop and think about it, doesn't it feel completely counterintuitive? Of course, it's absolutely true that a solid block of iron sinks. Iron is a far heavier material than water. Compare the two at the same size, and iron weighs about 8 times as much. So why on earth does an iron ship float? The key is a force called buoyancy. Let's start with something familiar. When you sink into a bath, your body feels lighter. That feeling of floating up in a swimming pool, that is buoyancy. Water pushes back up on whatever enters it. That's the important part. So why does water push back at all? The key is the depth of the water. The deeper you go, the harder the water presses in. That's water pressure, the same thing that makes your ears hurt when you dive deep. The more water stacked above, the harder it pushes on what's below. An object underwater has a top face and a bottom face. The bottom face sits deeper, so the push from below is stronger. It beats the downward push from above, and the difference leaves a net upward force. That is the true identity of buoyancy. What's even more interesting is how big that force is. Buoyancy is exactly equal to the weight of the water the object pushed aside. When an object barges into space where water used to be, the displaced water tries to flow back and pushes back with a force equal to its own weight. Now the whole contest comes into view. Floating or sinking is just a way-off between two things, the object's own weight and the weight of the water it pushed aside. If the water is heavier, it floats. If the object is heavier, it sinks. That's all there ever was to it. Now let's apply this to a block of iron. Iron is small, dense, and tightly packed. Its volume is tiny, so it pushes aside only a little water. The iron's own weight beats the weight of that displaced water. That is why a block of iron sinks. And this is where the ship comes in. A ship stretches the iron thin and shapes it into a huge bowl. Inside that bowl, it can hold an enormous amount of air. The amount of water the ship pushes aside swells by tens of times. You can test this in your own kitchen. Crumple aluminum foil into a tight ball, and it sinks. Fold the same foil into a little boat, and it floats. The weight hasn't changed by a single gram. Only the amount of water it pushes aside has changed. Same weight, yet shape alone decides whether it floats or sinks. There's another way to look at it. Take the whole ship, iron and air together, as one single lump. Most of what's inside is air, so as a whole, it's mostly hollow and light. As long as that average weight is lighter than water, the ship can keep floating. A giant tanker weighing tens of thousands of tons works exactly the same way. The heavier the ship, the bigger you build the hull, and the more water it pushes aside. As long as the displaced water keeps outweighing the ship, it stays afloat, no matter how heavy it gets. And what happens when a ship sinks? If the hull is breached and water pours in, the space that held air turns into water. The ship pushes aside less water and gets heavier at the same time. The moment it loses the way off, the ship goes down. Let's wrap it up. What decides floating or sinking is not whether an object is heavy. It's the way off against the weight of the water it pushes aside. An iron ship floats because its shape is engineered to push aside a massive amount of water. Thanks so much for watching all the way to the end. On this channel, from an engineer's point of view, we dig into the everyday mechanisms around us, the ones you thought you knew, but maybe never quite understood. If today's story sparked even a little curiosity, I'll see you in the next video.